The previous lecture we discussed about the advanced encryption standard, the structure of advanced encryption standard, the key size of advanced encryption standard, and performed the operation of each round. Now in this lecture we will discuss about the detailed operation performed in each round. So in the previous lecture we said that the state store the block in 4 by 4 array. So these 4 by 4 array perform sub byte substitution byte for adding the key. After sub byte we use find the state. We apply the shift row of this state. After applying the shift row we find the state output. We apply the mixed column of this output, then we find next output of state array, and last we apply the add round key of the this state data and find the ciphertext. So one add round key is applied before the first round. The third transformation is missing the last. Any mixed column is the missing in the last. So transformation to provide the security advanced encryption standard uses 4 types of transformation. First is substitution, second permutation, third mixing, and fourth is key adding. These 4 operations are performed in each round of the advanced encryption standard. So AES, like data encryption standard, uses substitution. AES uses 2 invertible transformation. Substitution is done for each byte. A table lookup is used for substitution. Transformation done 1 byte at a time. Add the confusion effect. So according to data encryption standard, we use the substitution. In substitution, we use the diffusion and confusion method. So here we use the confusion effect of each substitution process, and substitution process is similar to the data encryption. Sub byte, the first transformation. Sub byte is used the encryption site to substitute a byte. We interpret the byte as 2 hexadecimal digits. So the sub byte operation involves 16 independent byte to byte transformation. The sub byte operation involves 16 independent byte to byte transformation. Like that, suppose state data is given. T is 4 by 4 and each byte is stored in 8 bit. So first 8 bit represent the row and second 8 bit, last 8 bit represent the column. So sub byte is converted, sub byte is transformed in another state like that. If A16 and B16 sub bytes are stored in this place like the CD16. If A16 and B16 sub byte, after the sub byte substitution transformation, S-box transformation, we achieved the value CD16 stored in this place. Now, the sub byte operation like that, this table, sub byte table is 16 by 64 by 16 by 16. It means is contained in form of hexadecimal to 16 row and 16 column. So total number of entries is equal to 256. of this box transformation. Means we apply input 1 and 1, yeah, 0 and 1. It means we apply 0 means 4 times 0 0 0 0, or 1 means 4 times 0 0 0 1. Then after input applying this input 0 0 0 0 0 0 0 0 1, then find after the substitution equal to 7. So store the value 7c in the next state. And for inverse S box, if value of 0 and 1, input apply 4 times 0 0 0 3 0 and 1. After perform the inverse S box, we write the value of 0 1 place equal to 0. So after the perform the sub byte, we store the value of the given table. For example, shows how state is transferred using sub byte transformation. The figure also shows that in individual sub bytes transformation create the original one. Note that Note that if two bytes have the same values, their transformation is also same. So state 0, 0, 0, 4, 12, 14, 12, 0, 4, 12, 0, 0, 0, C, 0, 0, 0. Now the store in this form 16 byte are stored in the state array. We apply the sub byte. Means 0, 0. Input 0, output first 4 row and last 4 digit of 0, 0 means 63. So value of 0, 0, 63. Similarly, in state transitions value of 0, 4, we apply the sub byte 0, 4, 0, 4 equal to 30, apply 0, 4 equal to 0, 4, 0, 0 equal to 63, 0, 4 equal to F2, 0, 4, F2 from. Now value 1, 2, 1, apply input, sorry, yeah, 0, 4, F2, okay, right, 1, 2 पे C9 होना चाहिए, 1, 2, 1, 2, C9, 1 for row and last bit represent the column. Similarly, we apply the inverse substitution of each byte. We find value of FA to 1, 4. F means row or A means column. Now next, apply the operation of permutation. So another transformation found in a round is shifting, which permuted the bytes, shift rows. In the encryption, the transformation is called shift rows, done at byte level. Order of bit in a byte is not changed. Order of bits in a byte is not changed, but shift rows transform shift rows to left. Inverse shift rows transforms shift rows to right. Shift rows and inverse shift rows are inverse of each other. So, figure of shift row transformation like that. If you state that row 0 is no shift, but row 1 byte shift, row 2 2 byte shift, row 3 3 byte shift means shift row is shifted in this way. For example, shift rows for row 1 is shifted in one position. Suppose S1 S0 comma 0 shift, sorry, row 0 no shifted, इसलिए first row is not shifted, and second row shifted by 1, third row shifted by 2, yes, and last fourth row means row third is shifted by third. Row start from 0 0 1 2 3. 0 is not shifted, 1 shifted by 1, 2 shifted by 2, 3 shifted by 3, like that. If apply the shifting of state array of given this state array, S10 is shifted by one position. So S13 shifted the here, S12 shifted, S11, S11 shifted this, and S0 shifted here. So S11, S12, S13, and S. This apply the second. This shifted this, this shifted this, this shifted this, and this shifted. So S22, S23, S20, S21. Apply the third means first shifted in the third position, and third position shifted in the 1 2 3 is shifted is the this position 1 2 3, and like that. This is the shift row operation. It's, for example, 87 F2 4D and 97, this is 0 row, therefore shift of row is not applied because it is the 0 shift, it is the first row. And here 90 is shifted in this position, 4C shifted in this position, 6E shifted this position, and EC is shifted in this position, like that. And here apply the second position, and here apply the third position, similar of the above example. Now inverse shift rows in the decryption of the transformation is called the inverse shift rows, and shifting is to the right. If we apply shift row apply according to this, and we apply the inverse shifting and shifted the value of right, so is a inverse of shifting, like that. This is third row. Third row is shifted 82. 82 shifted by third position. Sorry, is D4 is shifted in the 82 place. F1, FA, FA this, 63 this, 82 this. Like that. One position. So F2, F2, 63, 16, we find we shifted 26 is F2 and F2 here. Now according to shifting right, so F2, 63, 26, and F2. So this is the inverse of shift rows. Next is the operation of mixing. Now sub-byte in the intra-byte transformation, after applying the shift row exchange byte, word oblique, the permutation bit inside the bytes Mixing in inter-byte transform, that changes the bit inside byte. The provide diffusion at the bit level, use the matrix multiplication at a state column multiplied by the constant matrix to generate the new state. So in the mixing, the example of figure of mixing like that, the mix column transformation operation at the column level, it transforms each column of the state to new column, like that state. And that is mix column with predefined matrix. We multiply, then find this, and this is says the value of. This is the operation of mix column. Example: constant matrix used by the mix column and inverse mix column, like that. Suppose that constant matrix is and inverse matrix is this. And how find the inverse matrix? We find the inverse matrix with the help of the given table. So state transition array column of this multiply by predefined matrix and then find value are stored in next state array. So this is the operation of the mixed column transformation. Similar, we define the inverse mixed column. The inverse mixed column transformation is basically the same as the mixed column transformation. The mixed column and inverse mixed column transformation are inverse of each other. For example, shows how to state is transformed using the mixed column transformation. The figure also shows that the inverse mixed column transformation and create the original one. Like that state array of this and apply the mixed column, we find out this. And after the applying the mixed column for decryption, we use the inverse mixed column of given state. Next, operation of key addition. Now we applying add round key. Add round key proceed one column at a time. Add round key adds a round keyword with each state column matrix. The operation in add round key is matrix addition. So the add round key transformation is the inverse of itself. Now figure of add round key transformation. If state array is like that, we use the add round key of keyword and then find value stored in the other state. So is total is the operation of advanced encryption standard. So advanced encryption standard perform better security with respect to data encryption standard because the key size increases. In the data encryption standard, data is stored in ratio 4 column 4 by 16, 4 input and 16 output, while in the advanced encryption standard stored block in form of 4 16 by 16 table, and each word stored in the 4 by 4 matrix.